Hello guys, and welcome to R programming crash course. This entire script uses only R's built-in data sets and functions, so you can copy and paste this entire script from just my GitHub page into your R or RStudio, and we're going to have a number of sections, and we're going to begin by looking at the basic R operations, and we're starting with arithmetic operations, simply a simple arithmetic operation like addition. We have subtraction, we have a multiplication, we have division, we have exponential, among others. You can also create a square root of a number or compute a square root of a number. And what follows is variable assignment. So we are assigning 10 to x, 5 to y, and now the result is will be the final x times y. If you print the result, you need to get something like 50. And what follows is vectors, which simply are basic data types, and we have a vector of numbers 1, 3, 5, 7, and 9. So, and remember, the C function is a function that combines values, sometimes called concatenation function, and we print values. If we print the numbers, we get the vector that we stored there. I will have vector operations. For example, numbers times 2, it will multiply each of every element of that number, similarly to addition. And you can also have mean and sum of numbers. That's our vector of numbers, and as well as the length, which will count everything inside that vector of numbers. So section 2, let us look at data types and data structures, and this is one of the interesting moments in programming. Let us check how to check data types in R. So if we say class, the numbers, remember numbers was our numeric vector, and it will get us numeric. And we can also look at different data types in R, like text, which, like example, apple, banana, cherry, among others. Simply, this is simply a character of vectors. And we have also logical values, like true and false. And remember to give descriptive or meaningful variable names. And we have also factors, and factor we create using the factor key or function, for example, low, medium, and high, and these simply represent categorical variables. Now we have other interesting mathematical operation, matrix. How we can create a matrix data, like matrix of with values ranging 1 to 9, with 3 rows and 3 columns. And if we print the matrix data, then we need to get a matrix of 3 by 3. And we have the data frame, which is the most common data structure in R. Not just R, but also in other programming languages like Python, and maybe also basics like Excel. Now we are going to use a built-in data set, like in this case we're going to use empty car, which will be loading the motor trained car road test data set. We want to hit the empty cars, just viewing the first few rows, and we're also going to check the structure by using str command, and also dim, which means dimensions, gives us the number of rows and columns, and the names, which gives us the column names of our data frame. Moving ahead, on section 3, we are going to look at data manipulation, and right away we are going to see how we can access data frame elements. For example, empty cars, we use $sign to access column by name. We have also other method. You can use a square bracket. For example, this will give us the first row but all columns, and this one will give us all rows but second column. Then this one, now it's interesting, it will give us the first 5 rows and first 3 columns. Now we can also do some subsetting or simply filtering. For example, MPG with the a high MPG will be treated as this. So MPG greater than, cars with MPG greater than 20. And if we print this one, then we get a whole data set with MPG greater than 20 listed to us. We can also use subset function to do subsetting. So for example, manual cars, we need to subset our data set is empty cars, and AM is equal to, which means automatic, is equal to 1, which means manual transmission cars. And we print manual cars, then we'll get all the manual transmission cars. And now we have how to add new columns to our data set. For example, we want to add a column called kilometer per liter, and we have this function which we need to convert MPG to kilometer per liter, and you can head now that and you get our data set. Now by section 4, we are going to look at basic statistics. Some of the basic statistics include summary statistics, and this is how we issue this. We just say summary, and we are going to use empty cars with MPG column, so just for a single variable. And we can also do this with the entire data set or data frame. And we can also do some measures of central tendency, such as the mean of empty cars. This is simply to give us the average. We have also measures of spread, like standard deviation, which simply give us the standard deviation. We have also variance of MPG. This one will give us the variance. We also have the range of MPG, which will give us the minimum and the maximum. And we have now quantile for MPG, which will give us the quantile. And we're also going to look at correlation. We simply use core MPG and weight. So it means it will give us the correlation between MPG and the weight of the car. Now we are moving on to data visualization on part number 5. And we first of all load another built-in data set, and this time we are going to use iris data set, which is Edgar Anderson's iris data, and we want to head iris, so just getting the first or 6 rows of observation. So we want to create a basic plot like histogram which is simply a distribution of a single numeric variable. So we use hist. The main will be the title will be distribution of sample length, and the X label will be sample length, and color will be light blue. And as well, we can also create a box plot, which is simply a distribution by category. And we can create a box plot of sample length based on species, and the dataset is simply our iris dataset. And the title, we can say that it's a sample length by species. And we can also add X lab or X label as species, as well Y label as sample length. And we can also add some property of color, which will be light green, light blue, and light pink for different species. And you can also proceed by creating a scatter plot, which simply presents relationship between two numeric variables. And we say just plot iris sample length versus iris petal length, as well as say we can add on some main features like sample length versus petal length, and X lab can be like sample length, and Y lab can be petal length. So we can also add color aesthetics like as.numeric iris species, so which means we're coloring by species. and you can add a PCH of 19, which is simply a solid circle. And we can now add a legend. We need to add it at top left, and levels will be like species and sample length, and color can be 1 to 3, and PCH we're again using 19. And we can also create a bar plot, so and we'll use this time another built-in dataset, and this time we're going to use a plant growth dataset, and this one results from an experiment on plant growth. So we want to head the plant growth dataset to check some of the variables and observations. We want to calculate the mean weight by group. So mean weight will be our variable. We want to use the apply function of plant growth versus weight, and let us create a box plot of the mean weight, the variable we created, and we can add on the title as average plant weight by treatment group, and we can add the X label as treatment group and Y label as weight. We can add also other color features like light green, and we print. Section number 6, we are going to look at statistical testing, and we are going to start with t-test, which will compare the means of two variables. And remember, those two variables or between groups should be numeric. And so first let us prepare the data. So we want to create a control weight group, which will contain weight and from group of the control. And we also need a treatment weight from tree. And now we have independent sample t-test, which will be represented by t-test.test, and now we control weight and the tree weight. Now we want to print the result and check, and what follows that we want also to create an ANOVA, which will compare the means among multiple groups or maybe 3 and above groups. And ANOVA result will be given as AOV, weight compared to group, and data is the plant growth, and you can have the summary of the ANOVA result. You can also run correlation tests by simply creating an object called co-test result, which will be co.test, the sample length versus section 7. We're going to look at linear regressions. We are going to start with simple linear regression. And remember, regression gives us the relationship between numeric variables that you want to see, the relationship between the car weight and the fuel efficiency. So we're creating model 1, which will represent a linear model of MPG versus weight, and data will be empty cars. If we summarize our model, then we'll get the result. And we need to plot now the regression line to check how it relates. And this is what we get when we plot. So I will give you a chance to run these codes and have a look at yourself. So because this is simply a crash course, so Y lab can be like miles per gallon, PCH should be 19 and similar. So we also want to add some regression line using app-line function, which is for model, and the color can be red. And you want also to do some multiple regression analytics. So we're creating called model 2 and a lem function MPG in relation to weight, HP or horsepower, cylinder. Data will be empty cars as always, and you can now summarize our model number 2. In section number 8, we are going to look at data transformation. So we are still using a built-in dataset, and this time we are going to use a dataset called air quality, which is dataset that is based in New York air quality measurements. We can head our dataset of air quality to check the first few observations. Now we can also handle some missing values. You can check the sum of all the entire missing values from our dataset, and this dataset contains some missing values. And now we want to clean air quality dataset by using this function na.omit air quality, which will remove rows with ns. So alternatively, we can use other methods to impute the missing values by replacing with average. So air quality zone is .na air quality zone. So we want to use the mean of air quality to replace any missing values, but we also need to remove missing values. So we want now to create a new variable called temperature underscore c, so which means temperature in we want to convert Fahrenheit to degrees Celsius. And number 9, we were going to look at now control structures. So we are going to look at if-else statements, and for example we are assigning x to 10, and we're saying if x is greater than 5, then we need to print x is greater than 5, else print x is not greater than 5. So the result should be x is greater than 5. And we can look at for loops. So for I in 1 to 5, we need to print paste iteration I, which will print values from 1 to 5, which will be iteration 1, iteration 2, all the way to iteration 5. So while loop now follows, and we are creating a object called count, which will store value 1. So while count is less than or equal to 5, we need to print paste count is comma count. So it will be count is 1, count is 2, count is 3, similar. And now we need to stop when the count is 5. And you can use the apply functions. And remember, apply functions are more efficient than loops, and we can use apply to mean the sum of the empty cars. And for example, apply empty cars to and then mean. So in this case, 2 means columns and 1 simply means rows, so which means mean throughout the columns, and if 1 is mean throughout the rows. And what follows is functions. And remember, with function we can create our own data pipeline to solve a certain problem. And for example, we want to create a function to calculate a BMI. So function will contain the weight of a person and the height of a person in meters, and BMI will be the weight over height squared, and we want to return the BMI. Now we want to use the function, or to call the function back. So BMI result will be an object that will calculate the BMI of 70, weight in kilogram, and the person with the height of 1.75 meters. And if we print the BMI result, we need to get our result here. And now we want to create a function with some default values. So now we want to create person, and the function will be like function name is equal to guest. So that is the default, and the message will be like paste hello and the name. And if we return the message, then we will say hello guest. And you can create now a person, for example with name Harry, my name, and you can create the person which uses now this line number 534 uses now the default value. And moving ahead, we can now focus on working with factors, sometimes called also categories or category calls. So we want to use another built-in dataset in this section again. So in this case, we're going to use tooth growth dataset. It's simply a dataset that focuses on the effect of vitamin C on tooth growth in guinea pigs. And we want to head as a tradition our tooth growth dataset to check some few observation. As well, we want to check this data structures by using str function. And what follows also we want to convert some the dose to factor, which means categorical variable. So tooth growth, that is a dose column, we want to convert it to factor. And now we want to check the structure, and now we can do what we call cross tabulation of using the table function of section number 12. We are going to look at more advanced visualizations, and in this case we want to look at something called pair plot, which simply plots multiple scatter plots. And you can just use pairs iris 1 to 4, which means all numeric columns. We need to remove the species column, which is character format. And you can say the main will be iris data pair plot, which is our title, and PCH you can give it as 21, and background can be like red, green, blue. And now we have density plot. And simply the same, we can add the main as density plot of sepal length. We can also add X label as sepal length, and we can also add on the color aesthetics as blue. And a line width can be like 2. And now we can add another histogram, like histogram of iris, and we can also add the rag plot, which is simply individual data points. We want to save and export the data set. So we want to save the workspace, that is all objects. So we want to save dot image rcrashcourse.rda. So we'll have that as our data set. So we can also save specific object, like save empty cars iris file. It will be my data .r data. We can also export to CSV, like using write.csv empty cars, and then the name of that data that we like, and row names will be equal to false. And we can also as well load the save data, like load rcrashcourse.r data, or simply load my data. In section 14, now we want to use some useful built-in dataset. Section I want just to show you some useful built-in datasets. So to list all available datasets, we just use this function data, and we run. So we will pull all the available datasets from our memory, and some popular built-in datasets include empty cars, which is simply a motor trained car road test. We also have iris dataset, which is Edgar Anderson's iris data. We also have air quality, which simply is a New York air quality measurements. We also have plant growth, which is the result from the plant growth experiment. We also have tooth growth data, which is the data that represents the effect of vitamin C on tooth growth. Moving ahead, we also have US arrest, which is the data that gives data or insight on violent crime rates by US state. We have also faithful, which is the old faithful geyser eruption data. We also have diamonds, which is the diamond prices and attributes from ggplot2 package. We can also load a specific dataset, like a dataset US arrest. We can also head the US arrest. And section number 15, I'm going to give you some resources for further learning. So for example, when you are stuck with R, we just can use question mark main. So this one will help for a specific functionality. And we also have help, for example, LM is an alternative way to get help, for example, of LM, which is linear model. And example plot, this one will see example of how to use a function. And example of the data set, we have, for example, VGNet, which one, this one will show the available VGNet tutorials. And some practiced with other built-in data sets. We have data set on called faithful, which is simply the old faithful visa data. You can also still head the faithful data to fetch the first few observations. We have also some basic analytics of faithful data, and we summarize it, faithfuls, we get the summary of that. You can also plot faithful data based on weighting and the faithful of eruption. This is the conclusion. Congratulations, you completed the R crash course. You can explore more by trying other built-in datasets. To contribute learning or to continue learning, please practice with your own data or explore R packages. Thank you and see you in the next video.